Welcome to our deep dive into the world of meteorology and climate science. In this video, we'll uncover the intriguing mystery of why polar vortexes, these chilling wind formations, are appearing more frequently than ever before. We'll take a comprehensive look at the scientific theories and climate changes driving this phenomenon. So, if you've ever wondered why your winter seems colder or longer, keep watching to get a grasp of the intriguing dynamics shaping our world's weather. 1. Understanding the polar vortex. The polar vortex is like a massive whirlpool of frigid air moving around our planet's poles. Think of it as a barrier that, when strong, keeps icy polar air trapped up north. This barrier is formed by a sweeping jet stream, a fast-moving belt of air. During winter, this jet stream gets extra powerful because of the stark temperature differences between the warm equator and the icy poles. When functioning well, it acts as a shield, effectively keeping cold polar air from drifting southward and affecting regions in its path. 2. Historical perspective on polar vortex behavior. Historically, the polar vortex hasn't always behaved the same way. In recent decades, scientists have observed intriguing patterns. Between 1979 and 1996, weak vortex events only happened about 3 days each winter. But in the years between 1998 and 2015, they jumped to an average of 7 days. While weak vortexes became more frequent, strong vortex events dropped from 12 to just 6 days over the same time frame. This historical shift indicates a potential transformation in how the polar vortex operates and impacts our climates. 3. Climate change and Arctic amplification. Climate change, especially its impact on the Arctic, plays a pivotal role in disrupting the polar vortex. The phenomenon called Arctic amplification describes how the Arctic is heating up faster than the rest of the globe. This warmer Arctic reduces the sharp temperature gradient that strengthens the jet stream. As the gradient weakens, so does the jet stream, becoming wavier. This waviness allows cold air to escape southward more easily, while warmer air streams into the Arctic, leading to unsettling weather patterns. 4. Sea ice decline and its impact. The decline in Arctic sea ice adds fuel to the fire. Without its icy armor, the dark ocean absorbs more sunlight, warming the region further. This extra heat not only melts more ice but also shakes up atmospheric circulation. A diminished sea ice cover can amplify the movement of planetary waves, disturbing the polar vortex up in the stratosphere. When the vortex gets disturbed, it can send blasts of cold air to mid-latitudes, leaving places like North America and Europe feeling the chill. 5. Sudden stratospheric warmings, SSWs. Sudden stratospheric warmings, SSWs, are dramatic disruptions in the polar vortex's stability. In these events, temperatures in the stratosphere rise rapidly, flipping the typical flow of westerly winds. When the vortex is knocked off balance, it allows frosty Arctic air to spill into regions where it typically shouldn't reach. Although there's some debate, several studies hint that these SSWs have become more frequent in recent times, possibly due to the shifting climate conditions. 6. Influence of the Arctic Oscillation. The Arctic Oscillation, AO, describes a climatic pattern centered around the strength of winds swirling counterclockwise around the Arctic. In the AO's positive phase, the polar vortex is robust, keeping icy blasts tightly contained. But in its negative phase, the vortex falters, allowing chilly Arctic air to crash into mid-latitudes. Recent observations suggest we've been experiencing more negative AO phases, which line up with the increasing cold outbreaks seen recently in regions like the United States and parts of Europe. 7. Mid-latitude weather extremes. When the polar vortex destabilizes, it sends ripples across mid-latitude weather. Cities that usually enjoy mild winters can suddenly face Arctic-like conditions. Think back to January 2014, when much of North America got gripped by the polar vortex, leading to record low temperatures. These kinds of extreme weather events, linked to vortex disturbances, are becoming more frequent, challenging infrastructure and communities unprepared for such icy onslaughts. 8. Modeling challenges and uncertainties. Simulating the polar vortex's behavior remains tricky for climate scientists. For accurate predictions, models need to capture the interplay between Arctic warming and mid-latitude weather. However, current models sometimes fall short, struggling to accurately predict these complex dynamics. This underscores the necessity for continued refinement and improvement in climate modeling to better understand and anticipate vortex-related weather phenomena. 9. Future projections. Looking into the future, rising global temperatures suggest that polar vortex disruptions might become more routine. Climate scenarios predict that given current trends, we could face more frequent and severe shakeups in the polar vortex. This means we can expect greater weather variability, with conditions swinging unpredictably in mid-latitudes. Gaining insight into these potential changes is vital to preparing for future weather trends and minimizing associated risks. 10. Conclusion. The rising occurrence of polar vortex disruptions is a result of multiple interwoven factors. From Arctic amplification and sea ice changes to atmospheric patterns, these shifts hold deep implications for global weather. Continuously investigating these complex interactions is essential to crafting strategies that aid in both adapting to and mitigating our transforming climate.